So, hello guys. So today we are going to see the solution of a Pathfinder question. So this question is from Newton's laws of motion, and this is MCQ question number 8. So to read the question, it says a block is suspended from a uniform rope that passes through two ideal pulleys. So the pulleys are ideal here. So that means that there is no friction, and also the pulleys can be considered as massless. So this is the other end of the rope is tied to a fixed support as shown in the figure. So there is the fixed support over here, and if the pulleys are pulled vertically with forces F1 equals to 110 Newton and F2 equals to 90 Newton, the system stays at rest. Assuming linear mass density of the rope equals to 0.25 kg per meter and the acceleration of free fall equals to 10 meter per second square, find the length of the rope. Pulleys are not small. So if we think about solving the question, so yep, so okay, so if we first draw the diagrams over here, this is our first pulley, it is acting a force F1, and here is this, let's say this block is P, so let's draw, so there is this, and this is F2, and there is this fixed rigid support. Let's say this distance is X and this distance is Y. So I'm assuming that this support is providing a tension of T3, okay, and the weight acting here is MP into G. So about vertical equilibrium, we can say F1 equals F1 plus T3. This should be equals to MP into G plus F2 plus lambda into this part of the length of the rope is here is this is X, this is X, this is Y, this is Y. So I can set the length of the rope as lambda times 2 X plus Y into G. Okay, so this is our equation number 1. Let me write it in a good way. F1 plus 2 3, so is equals to MP into G plus F2 plus 2 lambda X plus Y into G. Okay, so this is our equation 1. So now there are several unknowns here, like this T3 and MP. We don't know anything about them, and also this is the length of the rope. So what we can do here is about we can see here that in this part, marking it, so in this part, okay, if you look closely, so what happens is the part hanging here and here, this is totally a symmetrical system, okay, and there is F2. The length of the rope under this pulley is something which is contributing to both in a same manner. So you can see if there is this T3, there is this T3 same, and the length is Y, so you can say 2 times T3 about this about equilibrium of this 2 times T3 equals to F2 plus 2 lambda Y into G. So this is our equation 2, okay, this is equation 2. And if we see this part, okay, so if we see this part, okay, I'm coming here. So for this part, we can see that as here is this T3 which was acting beneath it, T3, so here will be a T3, okay, and let's consider here another, this is tension T1 which is acting over there. And if we finish the drawing here, So as the pulleys are ideal, so there is no loss in uh, tension force over this surface, and I can consider that same T1 is here also, same T1 here. Okay, and there is this mass of pulley, so there is acting mp into g. So we can see from this is T1 equals to T3 plus lambda x into g. Okay, so this is our equation, and from this right part we can see that T1 should be equals to mass of pulley into g plus this length x, this is x, so plus lambda x into g. So comparing these two, we can say from these two, okay, from these two we can say T3 equals to mass of pulley into g. So this is the most important result using which we can calculate these things very easily. So from equation 1, if we put T3 equals to mp into g, so F1 plus T3 equals mp into g plus, I can say 2 times lambda x plus y. Okay, this is as L, total length of the rope, so lambda L into g plus F2. So you can cancel now T3 and mp into g, and we can find L equals to F1 minus F2 by lambda into g. F1 is given 110, this is 90, this is 0.25, and this is 10. So this is 20 by 0.25 into 10, so this comes out to be 8. So this is our final answer. So this is also given in the solution. Okay, so what we did here is that we break it in some parts. Like here we considered the vertical equilibrium of the whole system, which gave us this equation F1 plus T3 equals to mp into g plus F2 plus lambda times 2x plus y into g. Okay, and after that okay, so this is the equation, but we didn't use it, so let's just remove it. Didn't use it, so okay. Then considering equilibriums of this parts, of this parts and this parts of this parts, we could find these equations, like considering this part. So here this is F2 is acting downward, so we had like 2 times that equation. Okay, so that is not our concern here. So from this we got that this T3 should be same, and from here we got T1 equals to T3 plus lambda times x into g, which basically says that the tension acting there, it is supporting the length of the rope here, and we already got that those T3 should be same, this and this should be same. So we got that 2 of T3 should be equals to we can write it anyway. So this is 2 times lambda y into g plus F2. Okay, so this is this value of T3 anyway, and this and there should be this, and from the left hand side we see that T1 should be equals to mass of this block mp into g plus lambda times x into g, which basically gave us T3 as mp into g. Okay, so and from this equation, which we got as from vertical equilibrium, we saw that T3 and mpg cancelled out, so we got this as our final answer. Okay, so this is our solution. I hope you like it. If you like it, please considering subscribing our channel. Hope to see you soon with a new video. Thank you.